So we have 6 different ways in which we can choose 2 adults from the total of 4 that are available. Now, we also want to choose 2 teens. So we have teen 1 and we have teen 2. Well, if I want to choose 2 teens, and there are only 2 teens, there's only one way that I could do that. Well, again, order doesn't matter. It doesn't matter whether I say, hey, teen 1, join my team, or excuse me, team 1, come on and play, team 2, come on and play in the starting lineup, or versus teen 2 and then teen 1. So there's no order difference. Now look at what happens here. So if I consider the fact that now I want to pair the number of teens with 2 adults, and there's only one ordered pair for the number of teens, then here are all the possibilities. So I could have adult 1, adult 2, teen 1, teen 2. I could have adult 1, adult 3, teen 1, teen 2. I could have adult 1, adult 4, teen 1, teen 2, and so on, up until my last one down here, adult 3, adult 4, teen 1, teen 2. So if you look at this, well, there are 6 ways here. There is only one way here. In other words, if we had more teens, then we could possibly have another way in which we could choose exactly 2. Like if we had teen 1, teen 2, teen 3, then we'd have a couple more possibilities. But we're only taking from the group of 2 exactly 2 teens. Well, thinking about the area approach, we have 6 possibilities here, and we have 1 possibility here. So 6 times 1 gives me a total of 6 ways that I could choose 2 adults and choose 2 teens. Well, 6 is actually the same thing as 4, choose 2 of them. So just to prove that, we can come over here and do 4, math, choose 2, and we get 6. Now, this number 1, while you probably maybe wouldn't do it this way, that's the same thing as 2, choose 1 person. So 2, combination, 1 person. Oh, sorry, we're choosing 2 people. Pardon my. So we have 2 teens and we're choosing 2 of them. So let me change that 1 to a 2. Well, there's only one way you can choose 2 people from a group of 2 people. You either choose them or you don't. So what did we actually do here? We took 6 times 1 equals 6, which would have been the same thing as taking 4 choose 2 times 2 choose 2. So we can multiply combinations together when we're grabbing a subset of the group. So what we're actually looking for in question 2 is, out of the total number of ways you can grab 4 people from 6, how many ways can you grab 2 adults from the group of 4 adults and grab 2 teens from the group of 2 teens? So that was 6 times 1 over 15, which is equal to 6/15. So really all we did was 4 choose 2 times 2 choose 2 over 6 choose 4. Now, obviously, you don't want to have to draw diagrams like this every time, because if there were more adults and there were more teens, this might be a harder table to draw out. We're just trying to illustrate what multiplying combinations is actually doing. You're looking at all the pairs against all the pairs, and you're counting the number of ways those could happen. And then finally, what is the probability that the starting lineup contains only teenagers? Well, that would mean that from the group of 2 teenagers, you would be choosing 4 teenagers, because there are going to be 4 people in the starting lineup, and that is not possible, right? Because if you only have 2 teens and you want to grab 4 teens from the group of 2, that's impossible. So what we're actually trying to do in this case is, from a group of 2, choose 4. What's the probability of doing that? Well, that's from choosing groups of 4 from the total group of 6. This is 0. There's no ways you can do that. And there are 15 possibilities, so this would also tell us there's a 0% chance that that kind of team would take place. So this is just, the idea here is pretty much the same as what we've been doing all along, except now we're multiplying combinations together. We're looking for the number of orderings here times the number of orderings here to give us our final answer.